Hi, and welcome to the ONF Spotlight on 5G. I'm Timon Sloane with the ONF, and today it's my pleasure to welcome Navid Nikaein, board member for Open Air Interface. OAI has been working in the open mobile space for quite some time and has been pursuing a parallel journey to ONF in a number of respects. I think of us as fellow travelers pursuing transformation and using open source as a tool to help the industry along this journey. Navid, I'm really pleased to have you with us today, and I'm very much looking forward to your presentation. So with that, please take it away.
Thank you very much for the introduction. Welcome to my presentation. Today I try to explain you the story of open source for 4G and 5G, the journey we had since 2008. The title of my presentation is 5G transformation with open source. I try to a bit cover how open air interface has been evolved since the starting point. And please enjoy my presentation. Okay, open air interface is about commoditization of 3GPP technologies as wide, more specifically related to the radio access network and the core network, and bringing that into the open source available for everyone, such that the technology could be tested, validated in the lab, and the results could be compared across different organizations, different R&D centers. And also, one of the important aspects of open air is about the open API. And as the name suggests, open air interface, from the beginning, we always had in mind to open the radio access network in different ways through open source, but also through the open APIs. So open air interface at the beginning started as a Eurecom software development project, and later in 2014 we reached to the level where we wanted to consolidate the community, the people that are using or contributing to this software base. And this is where we created this OSA software, Open Air Interface Software Alliance, which is endowment found in a form of in a legal form. Yeah. So the objective that we set with Open Air, we would like to basically bring into existence a reference R&D platform, such that different developments, different experimentations, and different technology could be tested, compared, and shared across the communities. Also, as I said before, to consolidate the community such that we could have the contributors, we could have the workshops, we could have a point where people exchange the idea as a forum of hackers, developers, and even vendors, companies. Another objective that we wanted to achieve, and still we are not at the level of being really operational, is the standardization. We believe that with Open Air, with what this software could bring, we could contribute. We as a community, not as individuals, contribute to the standardization specifically to 3GPP. And this could be actually a voice into this community of 3GPP, and help for the standard, for 3GPP standards to go forward even more. Objective-wise, for the standardization, we also wanted that the results of experimentation in terms of choosing a technology in 3GPP, we wanted this to be also validated using the common R&D platform, which from our standpoint of view is very important to have this platform such that the technology is validated across different partners. The licensing model is also an objective for us because this segment of the network is heavily been researched, and there are a lot of IPRs around this radio access network, and to a less extent on the core network. So the licensing model plays a central role here to federate the companies and academic across the same software platform. If the licensing model is not appropriate, we cannot actually bring on the same table different players that are actually playing a central role in this software. And finally, the openness is also important to democratize the software and make it available for different players. In terms of the software stack and the license, so the software stack, we started back in 2008, the radio access network for the 4G, which later evolved with the core network and also some service-based platforms on the top. So there are, as you see in this picture, in the software stack, we have a number of platforms. So the baseline, the infrastructure is the radio access network and the core network, both for the 4G and the 5G. And I will later explain you the roadmap for both radio access network and core network, so you see where are we now and where we are heading. We also worked on software-defined radio access network, and specifically we developed a real-time controller. This development has project, and it was quite a successful project. And as of today, there are also a large community across this FlexRAN controller. We also worked on core network controller together with some edge services on the top of the core network. We also brought into the existence the concept of a network store and the SDK to basically make the mobile network just as an application, in a sense that due to the decoupling of the control plane and the user plane, a lot of network application could be developed easily with the help of the SDK, and then of course the orchestrator based on the latest cloud native tools such as Kubernetes. As you see, the licensing model is at the beginning was a bit heterogeneous. We introduced OI public license that I will cover later for the radio access network, and we used Apache for core network, and later we harmonized the licensing model. So today, the 4G RAN, 5G RAN, and 5G core network are all based on the OAI public license 1.1, together with the 4G SP Gateway C and SP Gateway U. The 4G MME and HSS, they are based on 3-class BST license, and the rest of the software on Mosaic 5G repository are all based on Apache v2.0. So here I have a better picture to kind of put things into the right box in terms of the license. So OI public license is kind of a Fran type of license for open source in 5G. And as you see on the left, the OI RAN, OI 4G UE, OI 5G UE, OI E node B, and OI G node B, they are all licensed under OI public license v1.1. And in short, this license is a derivative of Apache v2.0 plus the Fran clause. On the right-hand side, we see the core network case. So the whole 5G core network and the part of the 4G core network, they are also using public license v1.1. And only MME and HSS, they remain three-class BSD license. And everything above, like the service platforms, like the controllers, network store, and the orchestrator, they're all based on the Apache v2.0 as of today. So Fran type of license for open source in 5G has a number of advantages, and it is a subject of a hot debate. So it's not everyone that agrees with this type of license, but to our knowledge and to our analysis, this was the one, let's say, way to federate, as I said before, the the companies together with the R&D centers so that they can both exploit the platform. So this allows 3GPP members to contribute to open source and still retain the IPR benefit. So this license allows this allows to maintain the IPR benefits and also compatible with both R&D and commercial prototyping users. So at one side, there is this reference implementation, open source community, and 3GPP contribution, which comes more on the side of the open source. And on the other side, we have maybe some commercial usage. It could be only for feasibility and validation. It could be to reproduce the result that some other members of 3GPP produce just to cross-validate that the results are consistent. Or it could be even a technology transfer. So either of them could happen, and this license allows to do this, to have a technology transfer, to use the software for commercial purpose, or and still use it as an R&D platform. Another important topic is about the open source and standardization in a sense that they are becoming today complementary activities. On one side, we have the open source that enables fast innovations and development phase of the new technology. So this basically helps to quickly validate whether a given ideas are valid. And on the other side, the standardization could be let's say, seen as a long-term stability and interoperability for the software that is produced. So they become complementary, and we need to maintain both sides at the same time for the success of 5G, 4G, and beyond. And this basically gives rise to a clear need for open source for 5G, because then we have a lower for the entry barrier. So this basically helps for some players to enter to this value chain of the mobile network in one way or another, as a network function or as a service provider, to reduce TCO and improve the accessibility and the use of the different component in different setting. I have to mention that not all the deployment requires certain service performance and certain SLA. So depending on the deployment, some of the component might be used in order to reduce the TCO, total cost of ownership. And as I said before, a common R&D framework for innovations. Then, given that the objective from the beginning that we said, given the name we gave to our activity, Open Air Interface, we wanted to enable the Open RAN. So Open has different dimensions, different meanings. Open in terms of open source, it could be open in terms of the API, or open in terms of certain part of the software or hardware component. So at one side, the Open Air Interface, it's bringing the activity as a, let's say, consortium-led alliance where people are contributing and trying to have some open source software that they could use for their R&D activities. On the other side, we have an ORAN, which also target the RAN white box, the Open RAN, which is operator-led alliance. And the objective here is to have a more carrier-grade software, or also to bring some innovations on the top of radio access networks, such as RAN intelligent controller and so forth. So I would also see these two initiative as complementary, in a sense that one could benefit from the other if, of course, they agree on the same interface, which I would say in a short to medium term, this would be the case, maybe through the E2 interface that could happen, right? Maybe this could happen even at the level of certain API that two platforms they provide. And I would be very happy to see how this is going to evolve in near future. And the objective of the RAN white box, as defined by ORAN, as also defined by us to a good extent, is a specified API and interfaces. So today, the same as ORAN, we also have specifications for the API and the interfaces for the radio access network as well as core network. Open source network functions, maybe not the whole deployment is open source, maybe part of the deployment is open source. For instance, we could name the CU module in the radio access network might be open source. We could mention maybe in the core network, maybe the HSS or maybe MME is open source, like the Facebook Magma project and so forth. And also enable RAN virtualization and RAN intelligence. So all of this is in OSA, Open Area Interface Software Alliance, are kind of coordinated, and the roadmap have been devised through the members. So today we have a certain number of strategic members, including Orange, the Power Initiative in US, Qualcomm, Nokia Bell Labs, InterDigital, Facebook Connectivity, and Fujitsu, which actually helping us to define the roadmap for the RAN and the core project specifically, and also helping us to progress on the code base as well, depending on the partner. And also some some associate members. I can, for instance, mention Red Hat, with whom we are working in terms of cloudifications of the certain network component, most importantly core network, but RAN also is included. In the past, we also had some big collaborations with Canonical for the same purpose. And so there are other associate members here. We just mentioned a few of them, and they more or less contribute to different projects in the alliance. It could be the RAN project or core project or others. So OSA, with the partners, we have defined this project roadmap, and this is the project roadmap that we have defined for the radio access network. As of this year, our plan is to release GNode B for release 15 on non-standalone mode for the frequency range 1, together with the scheduler, which allows to have certain number of UEs connected to the network, and CI/CD framework to maintain that the code base is always tested and validated and has certain level of stability depending on the test case we are capable of doing. Next year, our plan is to move to release 16 and release the standalone mode FR1 plus FR2. Still, as of 4G, we have been working a lot on the functional split, and the NFAPI and the different splits are our target, together with the beamforming. CI/CD will continue to evolve based on the new features that have been introduced. And as of 2022, we want to move to release 17, include massive MIMO, and potentially include RIC and E2. I have to mention that the E2 will evolve over time. It depends on the availability of the RIC and E2, and maybe that component may happen earlier due to the interest of the community. In terms of the core network, our plan for this year is to release a basic version of 5G core network, release 15. When I say basic, it doesn't include the slicing modules. It only includes the main modules of the 5G core network, like UPF, AMF, SMF, and AUSF, and the plus the NRF function. We would like to release this with the support of HTTP v2 and CI/CD framework again. Next year, we target release 16. We want to include the slicing as defined by 3GPP and include the cloud native principles, apply the cloud native principles to the core network. More specifically, this would mean to make some of the network functions stateless, apply some microservice principles to certain function of the core network. And in 2022, we target release PCF function, and still CI/CD will continue. So as a short conclusion about the OpenAir interface, today we see OpenAir interface as a leading 4G, 5G open source initiative, in a sense that it takes the leadership in bringing new features, new functionalities of 3GPP into the software platform at the cost of, in some cases, compromising the stability. But we believe the features are important for R&D as of today. The day this software becomes commercial, I think the stability becomes the main target. That's why fast innovation is very important in the area of the 4G and 5G software platforms, as well as the services. So we do not forget the importance of the service, for which we developed some complementary software. And all of these service platforms, software platform, all of these are based on the open source technologies. And the final word is that OSA strives to foster cross-community collaboration. We believe, as in other initiatives like, for instance, Linux Foundation, even ONF, collaboration is really important to create and sustain disruptive technologies in 5G era and beyond. So please go through OpenAir interface, and if you find it interesting, join us, and we could create a very fancy technology for 5G and beyond. Thank you very much. And with this, I finish my presentation.
Navid, that was great. Thank you. And thank you so much for joining us today. And it's terrific to hear from you and from your community. And you were ending on ecosystem and a call to the ecosystem. And we're both in the open source space, and there are interesting environments where we're working on community and building things that are bigger than any one individual or corporation or whatnot. So I'm curious, with OAI, where are the bulk of your contributions coming from? Are they coming from industry? Are they coming from academia? What does that look like for you?
All right. So in the area of 4G, the main contributions came from Eurocom itself. So we did put quite a lot of effort. Just to mention one number, so we started in 2008 the development, among other activities that we have at Eurocom, and in end of 2013, we had the interoperability with the commercial equipment, like mix and matching, like with commercial UU, commercial core network, or commercial radio access network. So for the 4G, I would say that it was mainly Eurocom, maybe with some minor contribution here and there. In 5G, the landscape is a bit different. Like, still, some of the core contribution still comes from Eurocom, like for instance, the FiRAN, for instance, for the base station. But we have contributions for the user equipment that comes from the partners. We have contributions in core network. Some partners are interested in the core network. They contribute to for instance, AMF. They contribute to AUSF. So we have some contributions in 5G, much more than in 4G. I would say still the synergy, in a sense that people master the radio access network, is still not there. So in terms of the protocol stack, so some partners, they are quite comfortable with developing, for instance, upper layers, right? But when it comes to the lower layers, this become more difficult. And I would say our wish, our desire is that community understand the code, and then they become able to contribute to the code base. So we do workshops 2 times per year, and we do the training such that the community could learn and just not use, but also contribute and develop. So I could, maybe if I want to give a number, but this is my understanding, it's not an official number, I could say maybe still 70% come from Alliance, because Alliance has also its own resources, and Eurocom, and 30% or even a bit less comes from the outside. But this needs to be changed. As I said before, if we want to sustain the software, this needs to be changed such that we could reach to the high quality software. Yeah, this is our wish, but let's see if we can succeed.
All right, no, makes sense. And so if you could say a little bit more, so Eurocom, so what kind of resources does Eurocom have, and what kind of resources does your sort of consortium have, just to give everybody a feel?
All right. So in Eurocom has different type of resources. So we have resources that we are using for the development, but also for introducing our activity is more. We have 3 professors that are actively working on Alliance, on open air interface, code base, in terms of development, in terms of presentation. Then we have engineers, engineers that either a combination of junior and the senior engineers that are contributing to the code. And then we have sometimes some of the PhD students, so I could mention like 1/10 or 2/10, that they are able to contribute something. So not all of the PhD students are able to contribute something significant. Alliance has different type of resources. They have a person for CI/CD framework to maintain the certain level of performance, certain level of stability of the code base, and also has recently some developers to develop some of the features that have been collaborated with some partners. So some of the working that we have with some of the partners, so Alliance put some resources to work with the partner to integrate everything into the same code base.
Right.
Yeah.
Yeah, so that's interesting, because I think ONF is on a similar journey, and we found we need to have our own engineering resources too in order to build critical mass and to get going. And
the same.
you know, my next question to you is going to be if any of the, you use the term 3GPP vendors in your presentations. I'll reuse that term, but if you've seen any of those vendors contributing, and you also mentioned that you've made adjustments to accommodate Fran licensing to intellectual property protected contributions.
Sure.
Or to favorably treat those. Have you seen those kinds of contributions from those types of vendors as of yet?
Yes. We maybe not in the area where the innovations is protected by the IPR, but in terms of developing some piece of software to improve the, let's say, the usability of the software, this has been contributed by by one of the vendors that we have in the consortium. So I could say I know for a fact that some of the vendors, they use the software for some of the R&D activities they have, for the simple reason that if they want to do some R&D, their own product does not allow to to really experiment something custom, because even though those, they don't have access to the source code to change and modify. So of course they are not contributing back, but they are using. In terms of contribution, as you asked, yes, there are contributions, but it's not on the IPRs, it's on the boundaries.
Right. It makes sense, and makes sense for a whole bunch of reasons. But it sounds like a large part of the consumption is to use it as an R&D platform, and even the maybe the incumbent vendors have R&D activities where they're experimenting with different, functionality and are using your platform in that way.
Correct. Correct. You are right. You are right. Actually, they have the. So one hypothesis that could exist is that they develop some of their own IPRs, but this is not contributed back.
Right.
So right. It might be that the software is used as a, let's say, a R&D platform and some extensions to validate some of the IPRs, but we are not aware of that. But it's a possibility. It's a possibility.
Yeah, that's always one of the fascinating things about working in open source is there's consumption and there are contributions, and
exactly
there's always more consumption than contributions, and you never know what all the forms of consumption.
You never know,
right?
But this is something I would say that should have happened for 4G. It's the software allows that, and I think this could have happened. Yeah.
Right. Yeah. No, it's interesting. I mean, just a quick, interesting side story. We once just learned out of the blue that the air traffic control system of Brazil was running on ONOS, one of our projects. And we had no idea. Right.
Yeah.
And you talk about a critical lives, and just, I mean, so it is that whole consumption thing, and the blind consumption it can be fascinating. So, so thank you. That's helpful. And maybe the last piece on the ecosystem is the radios. You mentioned the lower layers, it's harder to find people with expertise. The radios are more and more specialized. You get into RF and all of that. So what radios do you work with, and how do you enable that in your platform?
You mean radio front end?
Yes.
And what kind of radio? Okay. So we historically, actually, our mindset was to support different type of hardwares, different type of architectures. Even we have been running our code base against the ARM architecture. So most of the usage of today is, of course, Intel based, but the software could also run against the ARM architecture. In terms of the radio front end, so we started with our own radio front end that we have been developing in the past, and then due to resources, we moved to National Instrument USRP platform, and then we expand to many different range of the radio front end. So for instance, Lime SDR, Blade RF, Iris, and even some commercials. So today, I think the landscape is quite good. We are supporting different type of radio front end. And I would say, given that we have implemented certain splits, functional split in the radio access network, that would give room to use some commercial radio unit. Of course, some development or some testing might be required. This allows, for instance, to just connect to some commercial products using the standardized frontal interface. So we support interface 8, 7.1, 7.2, and 7.3, 3GPP according to 3GPP specification. And hopefully, I think we will also support the ORAN interface. So that, I think, will heavily contribute to the ecosystem of the RAN in terms of having the ORAN interface against the commercial. So that is something we have looked, and we are looking as well.
Right. Yes, I think we're all looking forward to that. So once those interfaces become more standardized, exactly. You describe it as a standard 7.2 split, but it's not a standard really yet, right? So,
but just one story, we developed the frontal interface because we have been believing in Ethernet back then. So we started with a custom homemade Ethernet protocol, right, to create a remote radio unit against the baseband unit. But then this has been evolved. Xran specified the frontal protocol. You have CPRI, CPRI v2, and I think ORAN, I hope that this could become a de facto interface. So yeah, that would really improve the ecosystem a lot.
Yeah, very good. So switching gears a touch, you also talked about standards, and I think you mentioned contributing to 3GPP standardization.
Yeah.
And I'm wondering if, I mean, that's, people talk about open source moves faster than standards, but standards kind of bring kind of stability, but I'm curious if you've had cases where that's worked, where you've contributed to 3GPP and those contributions have had an impact.
Yeah, not to the level that satisfied our desire, but we did contribute in the context of some of the European projects for which there was a budget, there was a big industrial player in that consortium. We provided some input, and through that channel it went in. But the alliance has different agenda. Alliance, what we want to do in OSA is to have a representative, to have an actual representative of OSA, with which either the contribution that come from the community, right? Because we have different levels. I think we can follow, but our objective was truly to contribute to the extent that we can. So we didn't achieve so far this objective, but this is still among one of our objectives. And if we find the right person that is able to do so, I think we go forward. We see a good synergy here, but we did not actually exploit that. And us, as let's say professors, we are not, let's say, the best person to go to 3GPP. We really need the right person that we could feed with some information or some innovations or some results, and then we create that channel, right? We had, just a side information, we had some exchange with ETSI. ETSI is very close to Eurocom, so we had some exchange in that regard. And things seems to be positive, right? I'm not saying it's going to work, but things goes in a positive direction.
Yeah, good. Yeah, no, that's helpful. Thank you. So switching gears a touch again, now let's talk about your core implementation a touch. Just one thing I noticed when you were talking through the core is, you're talking about licensing, and you spent some time there, but for one reason or another, your MME and your HSS were not using your Fran license. They were remaining within the more permissive BSD license, if I recall. Yeah,
correct.
I'm curious why that is. Why
it is because we had a significant external contribution for MME. So we actually developed first the whole control plane of the 4G core network, including MME and HSS, with certain level of functionality. And then that code has been used as a baseline from some of our partners to improve and further increase the stability of the software, adding more functionalities, for instance, in terms of, let's say, I could mention handover, bearers, management, paging, and so forth, APN. And that's why it was a desire of that partner to keep it like that. Yeah.
Okay, good, thank you. And then maybe we'll wrap up, given our time. I have time for one more question, maybe. But maybe in the realm of deployment status and where it's getting used. And one other thing, if I recall correctly, you mentioned is I think he's like sort of a quote of functionality over stability, or kind of a focus on R&D, platform for R&D, and then stability comes closer to when it's getting commercially used. So I'm wondering where you are on that spectrum of getting towards commercial use and and live deployments or in various forms or whatnot? What are you
This is also a very good question because this is also one of the topics we have been looking specifically. My colleague, Prof. Raymond Knopp, he has been working on a specific project for the deployment. So first, to answer your first question, stability versus functionality, given that we have been working in different collaborative projects in which we wanted to show different type of innovations and also different partners they were interested in. For instance, they were interested in functional split. They were interested at some point in handover. They were interested in carrier aggregation, FAPI, and so forth. So we favored more the functionalities versus the stability because we could have keep the software monolithic from the beginning. It was much easier and we could maintain the better stability and better usability of the software. Yeah, so I would say the decision to go in that direction was more driven by the needs of R&D at that point of time. But it is true that we have been criticized that it's complex, right? And stability is not as good as the partners wanted. So we try to, let's say, due to the CI/CD framework we put in place, we want in 5G to retain this stability across different changes we are putting forward. Yeah, and so one good approach that I said we have been working with Red Hat along those lines is we deploying a campus network in Sofia Antipolis together with a bunch of partners, and the main data centers reside in Eurocom. So we have an indoor deployment and outdoor deployment. So we have like a very dense deployment of the RU, like in less than 100 meters, we have like 10 RU. So very dense and overlapping deployment across different floors, in our building. So we are putting the whole framework with the help of Red Hat, the whole framework of deploying core network and radio access network using, of course, the tools provided by Red Hat, for which we want to really put in a live network this development that we are doing. And this, hopefully, this will be accessible to everyone as well. Mm-hmm. So the name we gave, it's Open 5G Lab, as I showed in my slides when I presented the stack of OpenAir. And this goes through a bigger framework, European project that is called 5G EV. We have a lot of partners, including Orange. And the idea is to create a 5G facility. And this is sponsored by the European Commission. So this framework, at least, it allows us to improve our knowledge in terms of IT, because we are more on a telecom mobile network and maybe to a less extent having the deep knowledge on the IT. So we are upgrading ourselves in terms of having a deeper knowledge on IT, for instance, Kubernetes, SDN, NFV. And that would basically help even that is our objective actually, that our partners could reproduce the same infrastructure in their own premises. So we do it in Eurocom, in Sofia campus, to understand what are the needs, how this needs to be deployed. And once everything is ready, this could be reproduced somewhere else. Yeah.
Okay, very good. Thank you. Well, Navid, I want to thank you for sharing with us today, coming and participating. I think it's been it's
my pleasure.
And wish you luck, moving forward. A lot of exciting work, a great track record, and so again, thank you.
Thank you very much, and once again, thanks for the invitation. And I hope that this event will be very much successful. I'm looking forward to watching the keynotes, the different contents that you are going to produce.